storage analysis and implementation. What we've done in this paper, we compared actually several data mining mechanisms on both small and larger data. So I will be talking about that. So we know the importance of big data nowadays. Everyone is shifting to cloud computing. And I'm not sure the percentage as of now. We know as of 2019, we know 50% of industry shifted already to cloud-based computing. I should have checked the statistics as of now. I'm assuming this will increase way higher than that. So what we've done, again, we compared those, but let me just give you a brief introduction about the topic. Again, in big data, we talk about two major things. Big data, which comprise of the three V's: variety, volume, and velocity. And then we focus on the analytics part, which is divided into four main types: descriptive, predictive, diagnostic, and prescriptive. So what we've done in this research paper, again, we did basic analysis on the smaller and larger data, although the student didn't utilize cloud-based computing. We'll talk about the time consuming for big data analytics, but that's because we didn't have access to a more powerful computation power. So as for data storage, again, we'll discuss a little bit about this, and then we'll highlight actually issues about security. This is one of the major things that still need, although security measures have been studied for a while now, but there are still threats that we need to be aware of. Mainly for big data, the technology used nowadays is NoSQL, which it is non-standardized, so low-level query interfaces, more difficult to integrate with applications that you expect to use standardized SQL. So there is a lack of standardized interfaces that it will make it harder for vendors to switch to it. About the technologies that is used for NoSQL, there are many of them, like key value stores, where we store data in tuples, a key and a value. Column stores, I believe Google big tables use column-based stores, where you access data by column families, and then under each column family, you can determine what kind of columns. And the good thing about this, what you can store the data, you can store both structured, semi-structured, and unstructured data as well. Document-based technology, again, this is semi-structured and can be used, can be accessed using key value as well. And the fourth one is graph-based technology. This is suitable for storing data such as network graphs, images. If you're interested in seeing one of these platforms, there are many open source platforms, by the way. For example, in graph-based, there is open source called Neo4j that you can download. There is a commercial version, but you can download the free version and play with it. For a distributed system, one of the most famous is Hadoop file system. Offers you to store vast amount of unstructured data. It's specifically designed for large data files, and then you can do processing in bulks. So as for querying platforms, typically lots of systems offer a SQL-like interfaces. So there are simple examples like, for example, scan. I forgot what language is that. So one of the platforms that we talked about, scan, is similar to select select star from certain table in SQL. Instructions like put, similar to insert instruction in SQL. So most of these platforms will provide you with limited number of instructions that is SQL-like languages. Executing queries and translating in MapReduce. This is in Hadoop. And the benefits of that, it is flexible and gives you the opportunity to deal with varying types of data. Another example is in Pula. So again, most of those you can actually download and see what they offer. Nowadays, new SQL databases actually aim to provide scalability that is comparable to NoSQL databases. So similar to relational databases. And then while providing atomicity, consistency, isolation, and durability at the same time. And those systems will include an architecture that allow you to run larger number of nodes. So like high performance machines, system or a cluster without bottlenecks. Cloud storage nowadays become dominant, and again, lots of companies offer cloud-based storage. Perhaps Amazon AWT, one of the most famous nowadays. They have the largest structures. And other companies like HP, Dell have open source platforms that can be utilized as well. But again, security is a major issue for these platforms. So although lots have been done for security, but still security is one of the major concerns. As a matter of fact, CNN have issued a report last year that this is one of the major concerns in national security in general. And still lots of work have to be done on this area. As of the challenges for storage, again, because we dealing with a variety of data, so things like multi-source integration might become problematic. Still have issues related to velocity, so query latencies, volume, because we're dealing with large amounts of data, and then, of course, privacy and security. So in terms of analysis, again, we normally have input data. We do some kind of pre-processing, like transformation, integration, selection, gathering, and so on. We apply mainly machine learning, data mining algorithms, and we were looking for certain outputs. But again, I'm gonna skip this. Again, what kind of analytics we're looking for? the things that we focused on, simple algorithms like k-means for clustering. So again, you might be familiar with the algorithm. So this is just pseudocode. And then naive-Bayes prediction. So this is part of prediction analysis where we try to predict the probability of something to be certain class label. So for example, if we're dealing with patient data, we train the model to predict if a patient have a cancer or not based on a large amount of patients with certain attributes. So if a new patient come with these attributes, we want to predict the likelihood of this patient to have cancer or not. So for analysis, we need to be able to interpret and evaluate our results. So there are some metrics that need to be ensured. One of the things I think in this paper that was used is precision and recall. So one of the open source databases that we utilize, this is image database, consists of 3.5 terabytes, and we did the analytics on this data. So just to show you some of the work that have been done for naive Bayes, we imported certain libraries that will help us with analytics, like NumPy and Pandas. And then we did the calculation on this, and I'll show you the results shortly. So again, we use this data for training and testing. You can either split the data 80-20, or lots of people split it 90-10, like 90% for training, 10% of testing. Or you can use cross-validation, where you can use the whole data for training and the whole data for testing. And you do, like, if you do 10-fold cross-validation, like every time you do 90-10. So again, we ran the data, and I'm going to show you the results for the smaller amount of data, and then the imaging data as well. For k-means, again, we did the same in k-means, but this is for clustering. So this is unsupervised learning. One of the things that we've done pre-processing, we replaced nulls with zeros. And then we extracted the columns. We clustered using k-means with using the elbow method for k, so determining how many clusters. So just this is a simple example for 2. So this is using 4 clusters. This is 5 clusters. You can see this is this is a smaller data set. The x-axis represent the veterans population. So this is actually open source data. We try to predict or cluster a population of veterans who actually committed suicide. So you can see in the x-axis here is the numbers. This is times 10 to the power 6. You can see here, based on 2 million people, this is the cluster, about 700 actually committed suicide. So this is based on k equal 4, and this is based on k equal 5. We did this is just a schematic. This is just data, a sample data to see if this works. So we did the experiment using dbScan. So just simply running an array to see if it can display noise or outliers. And I'm going to show you the results on the images. So for the actual big data, so the data that you've seen, this one, the veteran data, this is small enough actually that you can run data mining techniques without the use of big data. But for the actual big data, we had 3.5 terabyte images. These images were taken aerial images using drones, and then represent functional maps of. So this is functional map of a world data set. These are unlabeled. So if it is unlabeled, we cannot do prediction, but we can do clustering. We can see how similar some images are to others. We did some pre-processing prior to clustering the big data. For example, resizing each image to be the same size, converting the data type from RGB to BGR, and then even the related data like float 32 format. But again, this is just well, I'll show you some of the libraries that we used. So Keras, sklearn for machine learning, OS for navigation, NumPy and Met to help us with math and so on. One of the things that we've done also, I want to talk about, we did PCA visualization. Normally you use principal component analysis to for feature selection, and because we have large amount of features, we have to limit those. And this shows you, again, this shows you in color which image is actually similar to which. You can see these are clustered nicely. You can see most of those the same color clustered at the same place. And this is one of the images, a small sample of a cluster to just show you most of the images, aerial images actually it looks alike. So those are clustered correctly. So again, what we've done, again, the small, we apply the prediction analysis in small data size, mainly the veterans data. And we've done minimal processing there. And then results is near instant. For the larger amount of data, we know we need more computation power, and then, but I know this might not be, since the data is large, we understand that you need more computation power to do the task. But we did a little bit more in pre-processing to prepare the data for the different tasks we want to do. So again, we try to highlight the importance of and the benefits of big data technologies. Everyone, we know everyone is shifting to that paradigm nowadays. We used 2 sample open source data sets to perform the work in this research. The first one is again, requires shorter time. And the analysis that we've done fairly done quickly, but for the image processing took very longer time. And again, although we should have tried a cluster of high performance machines, which we have in our university, but maybe this is one thing we need to do next.